Hello and good evening to you all. I hope all of you are doing well and all of you are in good health. In this short lecture, we will try and understand what is activity network and critical path analysis. Over the deliberations, we will try and understand what is an activity network, what is a critical path, and why its analysis is important, followed by description of its components, estimation of various timestamps, and eventually we will discuss Gantt chart and its creation. Now let us understand activity network with the help of an example. Let us consider there is a composite task T. T has in it set of subtasks starting from A to K. The execution time of the various subtasks that are listed in T are as specified. Now let us understand activity network with the help of an example. Let us consider a composite task T. T has in it set of subtasks starting from A to K. Let us assume that the execution time of the tasks A to K are as specified. Now here we have a tabular representation that highlights the predecessors and successors of the various listed tasks. For example, task A does not have any predecessor, but it has 4 successors B, C, D, and E. Likewise, task D has 1 predecessor A and 2 successors G and H. Likewise, H has 2 predecessors D and E and 1 successor J. Likewise, K has 2 predecessors I and J and no successor. From this tabular representation, we can make out that A here is the starting task and K here is the terminating task. Now let us create an activity network with the help of the dependency table. Since A does not have any predecessor, the network starts from A. It has 4 successors B, C, D, and E. Likewise, B has predecessor as A and successor as F. C has predecessor as A and successor as G. D has predecessor as A and successor as G and H. E has predecessor as A and successor as H. Likewise, F has a predecessor as B and successor as I. G has predecessor as C and D and successor as J. H has a predecessor as D and E and successor as J. I has predecessor as F and successor as K. J has predecessor as G and H and successor as K. Here, the vertex of the network represents the tasks and the transition, that is the edge, represents the dependency. Now, an important term that we need to understand here is a path. A path is defined as an alternating sequence of edges and vertices. For an example, here A, B, F, I, K is a path. A, B, F, I, K is path in this network. Here, if you carefully observe the activity network, with each and every task in the activity network, we have associated an execution time. For an example, with activity A, we have execution time 4. With the help of these execution times, we will try to estimate the total cost of a given path. Total cost of a path is estimated as sum of execution time of all the subtasks along the path. Now here we have estimated the total cost of the various paths. For example, for path A, B, F, I, K, The total cost is 32. ACGJK has total cost as 39. ADGJK has total cost as 41. ADHJK has total cost as 36. AEHJK has total cost as 37. Now let us discuss some of the important timestamps. To start with, we have minimum time. Minimum time is the maximum of all path from start to end. In the previous network, minimum time is equals to 41. The next timestamp that we have is early start. Early start is the earliest time by which the job or task can start. That is, maximum of all path from start to task. Early finish. Early finish is the sum of early start and the execution time of the task. Then we have late start. Late start is the latest time by which the job has to start. That is, late start is the difference of minimum time and the maximum of all path from task to the end. Then we have late finish. Late finish is the sum of late start and the execution time of the task. Then we have slack or delay. Slack or delay is the difference of early start and late start, or early finish and late finish. Then we have critical path. Critical path is a path along the minimum time. So critical path is a path along the minimum time in the activity network. Now let us learn how to estimate early start, early finish, late start and late finish with the help of an example. Let us consider the task C. Early start for task C will be 4, that is maximum of all path from start to task. Early finish will be estimated based on early start. Early finish is estimated as early start plus execution time of the task. Here, the execution time of the task C is 8. So, early finish for task C will be 4 plus 8, that is 12. Now, let us move on to late start. Late start, as discussed in the previous slide, is the difference of minimum time and maximum of all path from task to end. Here, the minimum time is 41 and maximum of all path from task C to end is 35. So 41 minus 35 will make 6. Based on late start, we estimate late finish. Late finish is the sum of late start and the execution time of the task. Here, the execution time of task C is 8. So 6 plus 8 makes 14. So late finish for task C is 14. Now let us consider another example. Early start for task G will be 14, that is along A and D. Based on early start, early finish will be estimated as early start plus execution time of the task. So here early start is 14, execution time of task G is 12, so early finish will be estimated as 26. Now let us move on to late start. Late start is the difference between minimum time and maximum of all path from task to end. Here minimum time is 41 and maximum of all path from tasks to end, that is from G to K, is 27. So 41 minus 27 makes 14. Based on late start, we estimate late finish. Late finish is the sum of late start and the execution time of the task. So here the execution time of task G is 12. So 14 plus 12 makes 26. So late finish for task G is 26. Likewise, here we have estimated early start, early finish, late start, late finish and slack for all the tasks that are there in the activity network. Here you will also observe that the slack for an activity along the critical path will be 0. slack for A is 0, slack for D is 0, slack for G is 0, slack for J is 0, likewise slack for K is 0. These are the activities along the critical path. Now let us create a Gantt chart based on the previous estimates that were made for the various tasks. A Gantt chart, for your knowledge, is a two-dimensional representation that highlights task along one of the dimension and time along another dimension. In a Gantt chart, for a given task, we will represent the timestamp between early start and late finish. Again, I'll repeat it. In a Gantt chart, for a given task, we will represent timestamp between early start and late finish. If you refer to the estimates, early start for A is 0 and late finish for A is 4. Likewise, early start for B is 4 and late finish for B is 15. Likewise, you need to create the timeline representation for all the tasks representing execution time and slack. Now this brings us to the end of the session. Thank you very much.